problem solving. Let me move my calculator. When we learn mathematics, the reason we're learning it is so that we can solve application problems. There are many different techniques that you use. You can use different techniques on the same problem. But you need to have a general strategy that looks something like this. The first thing you should do is read the problem. That's going to let you know what the situation is that you're working with. Whether you're dealing with a problem dealing with area, whether you're dealing with a financial situation, just read the problem until you understand what the problem's talking about. Then make a plan. And so in problem solving in real life, you have to make a plan. So the same thing is true in mathematics. You make your plan. Some techniques that might help you make your plan is to draw a picture. I like to draw pictures to help me solve problems. You might want to organize your information in a table. You might want to draw a graph. You might want to look at similar problems and similar solutions. Once you come up with your plan, you want to follow your plan. And then check your answer. Check to be sure your answer is reasonable. And also check to be sure that you have really answered the question. Because sometimes after you solve and follow your plan, you may still have to do a little bit more work to answer what the problem is really asking for. So let's look at one. Here we have a 120-foot long sidewalk that's 5 feet wide. If 125 cubic feet of cement are evenly poured to form the sidewalk, find the thickness of the sidewalk. So here's my sidewalk. I'm going to start it here. I'm going to go way down here, 120 feet long. Oops, there's not a very good sidewalk there. So we know the length of the sidewalk is 120 feet. We also know the width of it is 5 feet. The amount of concrete, or the amount of cement it takes, is 125 cubic feet. So that 125 cubic feet is actually the volume of this slab of cement. When we're dealing with a box, a rectangular solid like this, we find volume by using length times width times height. We know what the volume is. The volume is 125 cubic feet. We know what the length is. The sidewalk's 120 feet long. And we know the sidewalk is 5 feet wide. What we're looking for here is the height. So let's plug in all the numbers we know. This will be 125 cubic feet for the volume, 120 times 5 for the length times width. The h will stay a variable. So I'm going to multiply the 120 times 5. That'll give me 600. So I have 125 equals 600h. Then I just want to divide by 600, and that will give me my height. So let's see what that is. Let me turn it on. 125 divided by 600 gives me kind of an odd decimal here. Let me bring that over here. I get that my height would be 0.208 with a 3 repeating. So I might round that to say the nearest tenth of an inch of a foot. This would be 0.2 1 feet if I round it to the nearest hundredth. But this is feet, so it would be easy for me to take that and multiply it by 12 to get the number of inches. So it's going to be, the height is about 2.5 inches. I also could have taken my 125 over 600 and reduced that fraction. So I could have also gotten a 5 over 24. So pay attention to the directions to see if they want a fraction form, a rounded decimal, number of inches, or here this would be an exact answer. There's a problem dealing with the national debt of the United States. In 1970, the national debt was approximately $370 billion. The population was 203 million. Find the amount of debt per person in 1970. So when you see a problem like this, and we're trying to find a rate here, something per something, the question really tells you what you want to do. We want to find debt per person. So that means we want to divide the debt by the number of people. We know the amount of the debt is 370 billion over 203 million. So I just need to do that division. 370. Then I need 9 more zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3. Divided by 203. Now I need 6 zeros. 1, 2, 3, 1, 2, 3. That gives me that the debt per person was $1,822.66.